This is a presentation of SBE 15, New York City.
A very quick introduction. So you already introduced me. Reggie, well, Reggie works for, so Broadcast Telecom is my company, and I work very closely with an agency here in Denver called Tech Efficient that works with Intellisys. Intellisys is one of the largest national master agencies and has contracts with, I think, 260 telecom and IT providers. And so what we do is we help people find the right solution and help get it set up and help maintain it throughout its entire life cycle, and no charge to the customers. We get paid by the providers. So, but Reggie, I'll have you say a few words about yourself, and then we can move on.
Sure. Reggie Jeffrey, a solution engineer for Intellisys that supports Dan and his team. Essentially, what I do is I'm a regional sales solutions engineer. So we have 7 to 8 main tech stacks that I'm able to talk to and talk from and help our clients and partners go through discovery processes, create education portals, education on-site events, and generally understand and vet out any suppliers that we work with. So I come to solutions with an agnostic point of view, not having particular supplier or anybody in mind, but just looking to solve the issue or design the issue that needs to be deployed. And I'm happy to join you all this evening.
All right, thank you. So I wanted to start out with a quote from Jacob Daniluk with Tyline, who some of you may know. He was kind enough to provide a quote for me. For the most part, SD-WANs are the same. They look the same to codecs as any other network interface. It's just a traditional IP network with a routing table that they can refer to for network routing. But it's because it works, really well. It's something that they like to have customers use, and it works out well for all concerned because it's reliable and high performing. And the next quote is one from Jamie Till with Sarkis Tarzian Radio. And this was something that Tyline had put in their newsletter. And Jamie and Jacob, gave the go ahead to use this. But Jamie, basically, I won't read it, but he, was using fiber, leased fiber, and it was overkill and expensive. And so, like a lot of people, he heard about SD-WAN, wanted to try it out, and so he went to Jacob, and Jacob said, "Yeah, that'd be a great idea." And so he went ahead and deployed it and has been using it, and is very happy with it, and has saved a bunch of money. So I'll toss it back to you, Reggie.
All right. So SD-WAN, what is it exactly? So software-defined wide area networks, and essentially what that is it's a mix of, or at least a conjunction of, an orchestrator that lives in the cloud or off-premise from where your applications are, that controls edge devices, which sits next to a firewall on-premise to where you are at your brick and mortars, and gives them network instructions. So that gives you the ability to connect more than one internet service provider, more than one type of internet connectivity, whether that's cellular, wireless, satellite, uh, broadband, or direct internet access, or what we call DIA, and even MPLS and virtual private network systems. So all those can be connected, and the SD-WAN will select the best path to send your traffic based on a scenario. And we'll dive deeper into the scenarios. And it also gives you a very high availability, and we'll talk a little bit about that as well.
Sort of the overarching traditional definition of SD-WAN is that it separates the control plane from the data plane. And it grew out of SDN, or software-defined networking, which came to be a thing about 20 years ago. And SD-WAN was really the first application of it that was used quite a bit, and it's become the predominant WAN technology. So, go ahead, Reggie.
All right. So at a high level, what does that mean? So we typically say that means any application, any connection, any user, and anywhere. So let me break that down a little bit. So as software moved from being installed directly on an endpoint or a computer or a pad or a server, most of our software as a service now exists in the cloud. So the probably the biggest example I have to give is how Microsoft Office and Teams works. Those applications, you no longer go to Best Buy, grab a disk or grab a key and install it on that computer and then wait for the next year for the next version to come out and do it again. Now, that's something that you subscribe to that exists in the cloud. And so now most there are other applications, maybe voice over IP or CRM systems. There's quite a few applications that live in the cloud. So now SD-WAN gives you the ability to have what we call a gateway or an on-ramp directly to those applications. When we talk about any type of connection, we talk about what I was describing earlier. You can have multiple types of connection to an SD-WAN solution, whether you have a Starlink solution via satellite or a microwave solution point to point. Um, a lot of folks are now using cellular, whether that's 5G or LTE, long-term evolution type of connectivity, or traditional broadband copper or fiber to your house. That's another type of solution that you can get. All those connectivity points can connect into an SD-WAN and give you a redundant solution. Any user, when we talk about any user anywhere, when COVID came around, a lot of us went back to working from home. And then when it kind of cooled down, some of us went back to the office, some of us stayed at home. So companies need a way to have a consistent internet connection, not only to their point of presence where their brick and mortar networking is, they may also need to have their remote users connect to the cloud. So having a secure connection to not only your office, but to the cloud for folks who work in the field or off campus allows us to do that. And anywhere. So this goes back to anywhere. You companies are international now. I still need to connect with my Japan branch in Japan versus my branch in Brazil and my branch that are in the States. They still need to have one connectivity point or at least one network infrastructure. And SD-WAN allows you to deploy at those locations and do natting accordingly.
Great. And one thing I wanted to clarify, um, which is something actually that I wanted to touch on, is you mentioned microwave point to point, and in the broadcast industry, generally we talk about that. It's their 950 megahertz STL. But I think what you were referring to was fixed wireless, so as an internet connection, which a lot of broadcasters use as well. So basically, yeah, any type of internet connection. But it also works. It integrates with MPLS. So a lot of companies that traditionally have had MPLS um, are sort of migrating off that gradually as their contracts expire and integrate it with SD-WAN and then terminate the MPLS and end up saving quite a bit of money. And then also, a lot of um, broadcasters use private connections as well, like Ethernet private line, and still some T1s out there, of course. But yeah, so iHeart, I know for a fact, and other station groups are starting to have. I think it's been a little while, but are switching from actually many of their um, RFSTLs to SD-WAN. And so what I wanted to cover next was what has driven the adoption of SD-WAN. So some of this is applicable um, to you folks, and some of it's not. I mean, a lot of the driver again is that a lot of the cloud is where the apps reside now, and traditionally applications resided in a company's data center, whether it be their data center in their building or in a colo facility. But that's the way traditional WANs were designed, and they would backcall internet for the various locations, at least most of the time, out of via the private network through the data center instead of having to deploy and manage firewalls at all the individual locations. So that's a very inefficient use of bandwidth, and it creates a lot of complexity. But as we all know, software as a service is where most of the apps reside, and so in addition to the applications that are part of an infrastructure as a service like AWS and Azure and GCP, Google Cloud Platform. Um, and so, anyway, one of the drivers of SD-WAN was that it enabled people to securely connect from any location to the cloud to access those applications without having to do like a hairpin connection back through a data center and connect securely and with a high performing connection as well. So yeah, instead of MPLS and private lines, it's a lot cheaper. And let's see. So, and it enables these, we'll talk about these features, but what SD-WAN enables is dynamic path selection, traffic shaping, forward error correction, and it prioritizes the apps that you want to prioritize, the apps that need to be prioritized, and reroutes them around congestion or outages in real time. And finally, improve security, and we'll talk about that as well. And then I wanted to point out that Gartner specifies 4 key capabilities: lightweight replacement for traditional WAN routers, which MPLS routers, by the way, are very expensive, and support for multiple connection types, dynamic path selection, a simple, intuitive WAN management and monitoring interface, which is a big part of the appeal, the centralized control, and then support for secure VPNs and integrated third-party network services. The next 4 slides cover, I'll run through these pretty quickly, but it's, you can deploy SD-WAN yourself. You don't need an MSP or a telecom company to manage it, deploy and manage it for you. But so I just wanted to provide a little comparison on managed versus self-managed. If it's managed, then obviously you don't have to worry about the setup, the updates, the troubleshooting. You get 24/7 support. It's usually deployed more quickly. You have more options for integrated security services, and you have one throat to choke, but you do have a little bit less control. It's going to be more expensive, and you're locked in with that vendor for the length of the contract. If it's self-managed, you have more control. You can customize it, and you're going to save some money. Self-managed, you do need some level of skill, and so you need more. You need resources, and you need IT resources, and longer deployment times, and responsibility for uptime. So if it breaks, it's not on someone else to fix. With that, I'll toss it back to you, Reggie.
Sure. So this is a bit of a really high level basic topology along with some terminologies around SD-WAN. As we talked about before, the orchestrator, the controller is essentially the brain, the application, if you will, that lives in the cloud that is the control point and gives direction to all the edge devices, the devices that sit on locations. From there, you have a portal that you can log in, make changes to your network infrastructure, set rules and standards and different netting rules that you can to report to the orchestrator, or at least offer some control to it. And those can be distributed across your whole wide area network, as opposed to having to log into each individual edge device in a traditional fashion. SD-WAN edge is where the internet ends and comes up to where your network infrastructure begins. That's why they call them edge devices. They sit at the edge of the internet, and then sitting next to your device, next to your networking devices, and gives those instructions, and also has visibility in some instances to your internal infrastructure. Application flow basically determines where applications sit in the cloud, how you're sending packets back and forth. So whether you're replicating packets across multiple paths or load balancing, or even doing a strategic routing. Maybe I want a certain packet go down one route, and maybe another packet could go down another if I have multiple internet service providers plugged in. And I think we have a slide that will
Yeah,
display that
yeah,
a
we
little
can
bit
dig
better.
into we'll dig into the
Yeah.
application for a little bit. Yep.
Yep. Internet breakouts and virtual tunnels, like your virtual tunnels or your VPNs that you can set up. Um, Even though a lot of folks do use SD-WAN to replace old VPNs or MPLS infrastructure, some folks like to keep that in for specific reasons. Those will also connect into an SD-WAN infrastructure and will also receive instructions from the primary controller orchestrator.
Okay. By the way, like to keep this interactive. If anyone does have any questions or comments, then please feel free to chime in.
I'll also
Read.
keep an eye on the
Muted
chat as well.
everybody because there was some background noise, so you'll have to turn your mic on first. Unmute yourself.
And I'll keep an eye on the chat in case someone types
Yeah.
anything in.
Okay, great.
Thank you.
I'm only looking at the presentation. So
Okay. All right. Next slide.
okay, yeah.
So this is just a high-level demonstration of more of a traditional WAN infrastructure setup. I came from a pretty deep technical background for an MSP, so I quite often have to go on sites, make changes to the router, make changes if there was a storm or an outage where I would have to literally plug and unplug and plug in the available MSP, and then of course make changes. Uh, in the case of emergency, it's led to a lot of late night calls for me. So this is a difference between the SD-WAN. That is one of the major advantages is all I need to do is make a change on the controller from my portal, and it will go ahead and propagate that across all edge devices that are connected to the SD-WAN infrastructure. So I can uniform my changes. If I do need to make one custom change for one location over the other, there's no need to go on premise or or a remote desktop from your location from a server and then remote into a firewall to make those changes individually. It can all be done from the portal that connects to the controller or orchestrator. Okay. All right. So we talked a little bit about SD-WAN gateways. One of the advantages of SD-WAN, when we go back to saying, any application anywhere, the advantage is you're able to create these gateways or on-ramps or short connectivities to where your application live. Uh, I'm very near multiple data centers, and I do know that we have an on-ramp for Office 365 and one in downtown Dallas. If I'm someone who has an organization there and I want to have a quick connection to those Office 365 tools, maybe my SD-WAN is set to configure so it's going into the closest gateway. This often helps cut down on high latency. You want a low latency connectivity. So having gateways in place, even having gateways to your data center that may be hosted in an office or a co-location location helps with replication, helps with backups, helps with disaster and recovery. And then, of course, all the edge devices are going to be placed at your remote locations, whether you're a retail store or whether you have multiple broadcast stations or even multiple back offices that you need to connect to.
Good. Let's dig into the application flow.
Okay. So application flow. So we talked a little bit earlier about how packets move across an SD-WAN. Not all SD-WANs are the same. So you can configure them to your specific needs. So I think we have three basic ones here. But essentially, this load balancing will say, okay, I've got packet one, packet two. I've got two internet service providers. So maybe I have one that is a cellular one. Maybe I have one that is a physical one through fiber. Um, Maybe I want to route packet one downlink A, while packet two is downlink B. I often use the example that I work into the evening. from time to time. So I take calls past my local time of 6. My kids come home, they jump on Xbox, they jump on Netflix. It makes it hard to have calls when you're experiencing jitter from multiple devices reaching out to the internet. So one of the things I've configured within my particular SD-WAN is at a certain time of day, I'm routing all Netflix traffic down the wireless connectivity. I'm routing all Xbox traffic down to wireless connectivity. And then any traffic coming from my IP, from my work computer, my wife's computer, goes down to physical connection. And after 9 o'clock or so, I turn that protocol off within my SD-WAN. I know a lot of organizations that do something similar. So it's a really good example of load balancing. Uh, that way, it keeps the traffic that you want to be prioritized, and QoS available for that. So that's one example.
Yeah, but I think it's important to point out as well that you can set those policies, but it also does it in real time. So if you don't set the policy, then it might not work exactly the way you want it to work all the time. But you can certainly that's basically the whole premise of SD-WAN is to look at the condition of each route in real time and route the traffic accordingly.
Right. So standardized feature. Uh, this kind of goes back to what Dan was saying about the real time changes made. I'm going to go and use the analogy that, again, that, hey, when 5 o'clock, 6 o'clock hits around my house, that's normally when everybody's home. So if I have maybe what we call a broadband connectivity and maybe a wireless one, even though I have broadband and I've got 300 megabits per second, because it's a big highway, so to speak, that I can go 100 miles per hour, everyone is on that highway at a given time. Well, I've got packets that need to go out. So maybe the highway that is represented as a wireless solution is faster than the one that is a broadband solution. So the SD-WAN knows that, it realizes that maybe this is not the best route to send your packets out. So I'll go link A because link B is busy, or 30 minutes from then, that can completely change. And maybe link B is the slower link or the faster link. So it makes those changes on the fly. If the protocol is to look for the fastest route for your packets, depending on the scenario of traffic availability on that ISP.
Great. I forgot to look at exactly what time we started, but I'm thinking maybe another 5 minutes or so, Bud. Does that work for you?
You're fine. Yeah, you're fine on timing.
Okay, thanks. Okay.
Mm.
Go ahead, Rich.
And then packet replication. So this is often used when streaming. This is often used in voice over IP communication. Uh, you go out on a phone, it sounds what we call jittery. It chips a little bit, or if you're watching a live stream or a broadcast, it stops and goes, it glitches out a little bit. So a lot of times you want to do, especially if you're broadcasting or even doing some sort of multicasting, we want to make sure those packets get to those endpoints. So what the replication is doing is now it's sending it down all my lines for internet service providers, link A and link B. It's blasting these packets out on both lines just to make sure that the packet gets to where it needs to go. So it's a form of redundancy, a form of a high availability. So it makes a really good scenario for those who are broadcasting or have a call center where the priority type of packets are voice packets or audio or video packets.
Okay. Don't know if we need to, go through the whole slide. Do you want to maybe point out a couple of these sort of advantages that are interesting to you, Reggie?
Yeah, I think the most interesting ones would be the redundancy and high availability. My internet is always up.
Mm-hmm.
As Dan mentioned before, this happens automatically and seamlessly. So even with regular traffic going back and forth, you will never know your speeds always stay high and available because the SD-WAN is always switching to the best routing. It's also helpful in disaster scenarios where um, I know here in Texas, Corpus Christi, Houston receives a lot of storms. I set a lot of our clientele base up on SD-WAN. So when the physical line goes out and power goes out, maybe my cellular connectivity is still up. I don't have to call someone to come out. I don't have to close down my emergency support center because they can't receive calls. The SD-WAN automatically switches to maybe a Starlink solution, which is satellite based, because I have a view of the sky, or a cellular solution, whether that's 5G or LTE, or maybe my cellular broadcast is out. I can automatically switch over to my physical connection, and A, you may not know when it happens, and B, you don't have to instruct it to happen. It's automatically controlled by the orchestrator. A couple other things. So that covers failover. You also have the ability to overlay types of security over an SD-WAN infrastructure. It's something we call Security Access Service Edge, or SASE. There's a lot of protocols and different scenarios and ways that you can configure that, but essentially allows you secure ways to transfer your data over the SD-WAN and different methods of doing that, whether that's allowing people certain permissions to get in and out to where they need to go, or even getting an understanding of where people are logging in at.
Okay, great.
And the other one is provisioning. I can easily provision a location. As Dan said, I don't need to hire a crew to set something up. I send them the edge point box, configure it in the portal. Anybody on site, all they need to do is plug it in, and now they have the protocols.
Yeah, and one thing I wanted to mention too, we're not talking about voice today, but and that sort of another driver for SD-WAN was being able to support voice over IP over just any internet connection. And so if it's configured the right way, then SD-WAN enables voice calls to actually stay up if one side goes down. So if you have two internet connections and you're on a call and one goes down, then it's seamless failover, and the person on the call doesn't even know that there was a switch to the other internet connection. So it's pretty high performing. Um, we can, I think, can probably just touch on this very briefly, Reggie. These are, just so SASE is Secure Access Service Edge, which is the new buzzword. But what it means is basically it's just SD-WAN with security layered on top of it. And it can all go in a single box. So there's a lot of appeal to being able to deploy everything in a single box and have only one box to manage. And you can see some of the features that you can get. So you want to just talk about real briefly about zero trust network access, Reggie?
Sure. So zero trust network access is, if I were to describe it at a high level, it's a more secured version of a VPN. It's a more directive remote login protocol. So take, for example, if I have a traditional VPN and I have an office and I VPN into my office, once I have access to that network in the office, I have access to just about everything my group policies will give me access to. I can go into different folders. I can look around. I can move around. I can fire up my RDP, remote desktop protocol. So, but with Zero Trust Network Access, what that does, it gives users, departments, remote users access to go specifically to a file, get what they need, or specifically to a group of files or a domain, get exactly what they need, and then turn around and come right back out. You don't have the ability to go around the network and move around as you would with just a virtual private network. So it helps protect files and giving people specific access to only ones who need that access. And it also creates analytics about who was in here, when were they in here, what files did they take, does someone need more or less access? Was there a breach or protocol? This is where the trail begins. So a more directed version of a remote access, so to speak.
Thank you. And I know we're going a little bit longer than I had said, but just a couple more minutes. I'm going to skip over this. I wanted to talk about, show you some of the providers. This is just a small portion of the providers, but you have like some providers that are simply all they do is SD-WAN, and that was their purpose for existing, or is the purpose for existing. Big Leaf, Cato are a couple. And then you have all of the telecom companies resell various flavors of SD-WAN. Cisco has Meraki and Viptela, which are two acquisitions that they made to get into the SD-WAN business. So you have the traditional firewall manufacturers like Cisco and Fortinet and Palo Alto that have their own versions, and VeloCloud is a common one too. But again, every telecom company does SD-WAN. So if you have all your services with AT&T and you want to stay under their contract, then you can get various different types of SD-WAN via them. And then finally, just a little bit about cost, because you're probably curious, what does it cost? You can get a little bit under $100, but probably $100 is sort of a good budgetary starting number per site. And if you don't need a lot of add-on features, if you don't need connectivity to like a cloud on-ramp to Amazon, and another factor for that determines pricing is the throughput. And as we all know, in radio, there's not a lot of bandwidth. There's not a lot of data throughput. So that's going to keep the price down towards the lower end of these ranges here. So, I would say probably start $75, $100 and go up from there. If anyone is interested in a design or a quote, what my job is to go out and find a few providers that might be a good fit, and then have them design it, have them quote it out, and I'm going to play them off against each other to get the best pricing, which is part of my value proposition, and then and help guide the customer to the right solution, help get it implemented, and that's it. So again, I hope you found it interesting and or relevant. And do we have any questions or comments at this time?
Just realize, guys, unmute yourself if you have a question. Not all at once.
I saw that David Antoine had a question in the chat section. He wanted to go over what equipment does one need to set this up.
Thank you.
Yeah. Well, there are, it depends on the vendor. But traditionally, it's just going to be the SD-WAN edge device, a rack mountable unit that has, virtualization capability for all kinds of different functionality. And then we're talking remote workers, for example, then it's generally going to be a software-based solution. So you don't necessarily need to have the hardware. But generally for a branch location, you're going to just have that single SD-WAN edge device. And again, it's plug and play, and you can configure all the devices at once. Do you have anything to add to that, Reggie?
The only thing I would add is they're also going to want you're also going to want to have a license to go with that.
Right. Sure.
The device alone, sometimes the licensing, and there's different types of licensing depending on the SD-WAN. Not a literal device, but it's not a standalone hardware, just a standalone hardware solution. So that also comes into play as well.
Right. Yeah, the licensing to connect, well, for the software and to connect to the gateway and to have access to the orchestrator as well.
Mm-hmm.
But the orchestrator is a virtualized application. So. All right. Anything else? Well, thank you for taking your time out. And again, any follow-up questions, comments, feedback is welcome.
Thanks for joining us. Please remember to subscribe to SBE 15 New York City.